It's yet another first author paper from your PhD called Wither AutoML, which I had to look up Wither in a dictionary. You can explain that one to us in a second. So in this paper, you interviewed machine learning practitioners to understand how they leveraged AutoML, so algorithms that automate kind of hyperparameter selection choices in models, or maybe even which model you use. And you concluded that currently the complete automation of machine learning is neither realistic nor desirable. So, what led you to that conclusion, and what future do you envision for AutoML tools?
So Wither AutoML, this title actually came from my advisor. The word itself means, what is the future of AutoML? And this is something I had to look up when he proposed this title as well. So we're in the same boat there, John. So what made us realize? So for this paper, we interviewed over 15 practitioners who are currently using AutoML solutions. We got to understand very deeply their use cases, the tools they were using, their organization, as well as their day-to-day work practices. What we found was that there is generally a lack of explainability to all the AutoML solutions out there. This was very problematic for them because at the end of the day, a human being is responsible for the model's behavior. And if they weren't able to explain what really happened and how we got to this model, that level of accountability simply wasn't there for them. Therefore, they really wanted to have a lot more control over the modeling process. I think it was great for some of them to be able to try out a bunch of different hyperparameters early on. But once you got to a stage where you're really thinking about productionizing a model, they wanted a lot more control. So that was part of the reason why it wasn't desirable to fully automate everything. And the realistic side was mostly about the ability for the systems out there to capture human intuition and human domain knowledge. Imagine if you're looking at a data set, for a drug prediction or something of that nature, right? For a AutoML solution, these are just columns of numbers. But for a physician, for example, some of these columns embed a lot more information than just these numbers out there, right? And they are able to bring their intuition into the process to help the model really understand the intricate relationships between the different features in there. So, and I think we're quite a bit of, we're still pretty far away from being able to somehow encapsulate the human intuition and human domain knowledge.
Right. So maybe this is the kind of challenge that Linea, maybe years from now, could figure out an answer to.
Absolutely. This is something that Linea is actually very excited about tackling in 5 years or 10 years' time. I strongly believe by that time, we would have a couple of things figured out. One is being able to represent human knowledge in a way that's a lot more consumable for the computer in the first place. And the second piece is, and this is what I think is absolutely crucial for AutoML to gain more traction, is to figure out how to make the human a collaborator in the process instead of completely trying to automate the human out of the loop.
Yeah.
And there's a lot of excitement about human in the loop computing today. And I believe in the next 5 years, we're going to see some amazing progress.
Yeah, I agree with you there. And that's where I see the interaction between humans and machines going. And by the way, this paper was in Chi, which is the most prestigious paper for these kinds of computer-human interactions, which is where the Chi name comes from. And so there's some people worry about machines taking lots of jobs, and they increasingly take automatable. That's a silly thing to say. Automation takes the most automatable jobs, takes the most repetitive jobs, but it does open up other opportunities. And this is that kind of example where tools may come up that automate aspects of a data scientist's workflow, but those aren't going to eliminate the data scientist. In fact, it creates the opportunity for there to be more data scientists having a bigger impact across even more models than ever before. Because yes, having a human in the loop with these kinds of interactions, it's the same kind of idea as prior to the 1990s, prior to Deep Blue playing against Gary Kasparov and beating Gary Kasparov. There was this idea of a human against a machine. And, for a while it was like, computers can't be as smart as a human at this complex thing like chess. And then it's like, oh crap, they can be. But what the great chess masters did then wasn't to discount computers, it was to work with them and to see how they could use guidance from machines to like, oh, what would I do here? And what does the machine recommend doing here? Okay, well, I appreciate that guidance in this case, or maybe that gives you an idea. But instead of doing what you're suggesting, computer, I'm going to go with my idea. And so that working together with the machine is a more powerful pairing than the machine on its own.
Absolutely. I think absolutely you hit the nail on the head, John, by saying what we're doing with automation isn't to outcompete the human, it's rather to augment the human, to give the human more opportunity to focus on what they do best.